Hello accounts people, time to have a look at investment appraisal. We're going to look at payback, ARR, discounted payback, then net present value, net present cost and IRR. We have a nice graph to help demonstrate IRR. These are the investment appraisal methods, capital investment appraisal or long-term decision making methods for capital investment on the AAT syllabus. ARR and discounted are strictly speaking only on the level 4, but I know a lot of good AAT teachers bring them in at level 3 because they do help. And of course it's all on spreadsheets. Well, it would be in the real world, and of course maths is now combined costing and spreadsheets. So let's start off with the payback method. So if you haven't learnt this one before, have a look at it and then try some questions rather than try going into the other methods immediately afterwards. You'll just get yourself confused. If you're a level 4 student, well yes, these are pretty much revision from level 3 with a minor tweak and a minor development. So what we've got here then, we have our payback table. All these figures are ballpark figures, they're very estimated. We're estimating, that's okay, we should know how much it's going to cost us, but we're estimating a £5,000 scrap value. We're also estimating sales income and operating costs into the future. So one of the issues is estimating for the future gets less and less reliable the longer you go into the future. So the payback period is very useful. How quickly do you get your money back whilst you can predict things? So we have capital expenditure and proceeds, we have sales income and operating costs. Sometimes these would be negative, would actually make the formulas easier. Sometimes you may just see the net cash flow, which is, in this case, the so take off the operating costs, not plus 7, the 7, that's better. Minus 60,000 as we would expect, and I'm sure you've already worked out we're expecting to see 31,000, 35 not in, 4 out, 35, 4 out, and then 30,000 in between the two items and 4,000 out. We are assuming that this money is coming in equal instalments. There isn't any seasonal variations, but in the real world there always are seasonal variations. And that money is coming in equal. Well, of course that 5,000 in particular is actually coming in at the end. But we look at the answer and we use our common sense on it. We take it with the proverbial pinch of salt. So our cumulative cash flow is our running total now at the start. It's nice and easy. It is just that figure. Next year though it will be a figure from year 0, our preliminary expenditure plus the money that's coming in. So at the end of year 1 it owes us 29,000, hasn't paid back. If we carry on the bottom 2 years, it has paid back at the end of year 2 and has earned us some good money by the end of year 3. It's a very positive, very promising investment. So we need to work out a bit more precisely the payback, and yes, it's sometime during the year 2. So, but we do have to remember that it's 1 year plus, because the calculation, okay, it doesn't like this equals, should have typed in equals. And then what we need to know is, in our formula, is we needed another 29,000 at the end of year 1 out of the 31,000 that comes in year 2. And then if we times it by 12 we'll get the answer in months. It would be silly to try and do 365 or 52, the system's not that accurate. So 1 year, which does actually mean and 11.2 months. If all your income came in at the end of the month, you would actually call that 2 years. You would round up. AAT exams will always say whether to round up or round down. Common sense required. So ARR uses the same data. That's why it's a very simple one. Once you've already done the hard work and you've worked out the cumulative cash flow, because actually we're interested in that 28,000 from our cumulative cash flow. and that was earned over 3 years. So if I then divide it by 3 of to the nearest pound, it's long numbers in the computer of course, as it should be in your calculator, and what I need to do is work it out as a percentage of the 60,000, not 600,000. And it works out at 15.6% or 16%. I've already formatted it as a percentage, so I didn't need the times 100. Now what I can do differently with this, I know how quickly I get my money back. I can compare that. How else could I earn 15.6%? Well, I'm not going to get it from the bank or a building society. I'm not going to get that in a casino. I'd struggle to get that year in, year out on the stock market. If I was good at plastering and decorating and fixing things, I might be able to buy up an old house, do it up and sell it and earn a bit more money than that. And method number 3 is a version of number 1. So I've already got this far, net cash flow, but now we're bringing in our PV factor, present value factor, or discount percentage, lots of different terms for the same idea. Now the whole purpose is we have estimated that the cost of money or inflation or what other items would normally earn us is 10%. And we're converting using a formula money received also or spent in the future on a later example in the future into today's money. So £31,000 in a year 1 won't be worth 31,000 now, it's going to be worth a little bit less, and we'll see that when we do the sums. So all I've actually got to do is take my present value factor and my net cash flow. That of course times 1 is still minus 60,000. So our 31,000 in a year is worth 28,182 now, to allow for inflation and other issues. It's an estimated percentage. Today 10% looks low because inflation is about 10%. But most of my lifetime that would be a fairly high one. We can put other percentages in very, very easy. We get the data, we can download a package into spreadsheets, or we can use the formula and create our own, or we can just go online and print one off. Used to be attached to exam papers at the end. They used to be as part of the appendix. The ones that are highlighted, so in 14 years time a pound is worth 34 pence today if the interest you would earn on it was 8%, or £1,000 is only worth 340. That's a long time in the future, way beyond most capital investment projects. So our cumulative cash flow is the same idea. Because we're now discounting it, it's always going to be longer, but the formula is the same, and it's now, so where it was still, it was negative minus 29,000, it's now a little bit more, and actually it had gone positive by then, and it hasn't anymore because I've discounted my money. So this number will come in later as well, we'll see that again later. So now the formula is 2 years plus, because it's 1, 2, it's in the 3rd year it pays back. So if I do my 6,200 out of, I've got to get the right figure here, got to get the 19,534, the discounted cash flow, or discounted net cash flow. Still times by 12 though. 3.8 months, so 2 years. Four months to the nearest. We wouldn't necessarily I can't see any reason for rounding that down ever on that number. So that's the first 3 methods dealt with, and we've introduced the idea of PV factors, so the rest will go a little bit quicker. Wrong one, that's the one we're after. So this is the standard version of net present value calculations. We've got the years going down, they could go across, they are in these tables here, I'll explain that in a minute. I'm using the same numbers and the same net cash flows, and in fact I'm still using 10%. So actually this is just the same. What have I done wrong there? I missed out a letter. That's better. We've seen those numbers before, but the net present value, we're not worried about the cumulative or anything like that, we're just worried about the end result. So I'm just going to add the discounted cash flows and discounted net cash flows up. And in fact I get the figure that we've seen earlier on, the discounted payback. So that item, that project, that investment has earned us £13,334 if the cost of capital is 10%. If it was negative, it would be losing us money. If we had another project that earned a bit more or a little bit less, we can take a decision, machine A or machine B. But machines often have similar patterns. So that's the very common, very standard format. Obviously the layout can be a little bit different years across. Net present value might be under year 0 sometimes. That bit would be greyed out. Not going to have that problem in the exam because you won't be able to type in the wrong place. So this one in the middle now is net present cost. It's a variation on a theme, and we have two vans. Now a van isn't going to make any difference to how much we earn if it's just a delivery van. It will however have a different expenditure pattern. So van R is a little bit more money to pay out in the first place, but it does get us a slightly higher scrap value. So notice these are all just positive numbers apart from the proceeds at the end of year 3 when we sell it. So we don't need to worry too much about minus figures. This one has, I think this is 16%. I know I've got 15% coming up later and the value's a 0.87, so I'm estimating that without looking it up on the table. We've got net cash flows. Notice we don't need to worry about the minuses. It's all about, does this van or this van cost us more money, and quite easily. Same kind of numbers, net cash flows, PV factors, discounted cash flows, and the net present cost is all these added together. So our van type P is 1158, our van type R is 1460. I think we probably need to put zeros after it really. So that's just a different application called net present cost. This actually is an old AAT exam paper or question from a long time ago. And then we could also apply it definitely at level 4, possibly at level 3, to do we buy or do we lease. So simpler version of the table, I've just got the net cash flow and I'm using 15% to 2 decimal places. Why not? Years down vertical instead of across. Well, doesn't make any difference. And what we're saying is that we're paying, on this version, we're spending £28,000 and it gets us a net present value of £22,910. Now instead of comparing it with another machine or another project, I'm comparing it with a different purchasing methods. I'm thinking about leasing it. Now if you lease something, it's going to cost you a little bit more money in cash terms, but your final payments are in 3 or 4 years, or in this case 4 years time. Which means 7,500 in 4 years time isn't 7,500, it's a lot less. So if you look at the pattern, the original investment is only the down payment, 7,500, and then in year 1, instead of 12,000 income, the net cash flow is 4,500 because we've got the lease payment. And again, even in the last year, 25,000 minus 7,500, that's not actually right, is it? I've not used a formula for that. I've used a formula there. I've been messing about with it. There we are. That's better. I've been playing around to demo to students. So actually that's now accurate, and if we leased it, it actually is earning us a little bit less than if we bought it outright, but of course our cash flow is better. We haven't had to spend £28,000. It's okay if you've got £28,000 lying around tucked up the sofa in a cardboard box somewhere, but most people and most businesses haven't. So that's a little bit less. So what I would actually then do is possibly sit with this on a spreadsheet, challenging the sales at what can you do. Can we change the lease amount? Maybe we can actually buy a little bit of a less as a down payment, and then suddenly it looks good and it works on paper. Having said that, those two numbers before were so close, I'd be very tempted because of the risk factor. I can often send something that's leased back after with a year's notice or in a month's or quarter's notice, and the fact that it's not damaging my cash flow so badly, it would actually probably carry this over this. This is an application of the same concept into a different situation, as is IRR. So IRR looks beguiling, this table. In fact, it could be worse because I've done 0, 3, 6, 9, 12 and 15%. I've got the numbers off a table. The table's online, easily obtainable. There is a formula you can use, so you could make your own, or you could actually get a bolt-on package into Excel if you used it regularly, and it tells you how the money in the future is worth today. The one that's highlighted, 14 years time, a pound is worth 34 pence if the cost of capital is 8%. Having said that, it doesn't matter what the discount factor percentage is, the outflows and the inflows are the same and the formulas are the same, so it won't actually take as long to fill in, even if I have copied in the discount factors for every percent, as I probably should do really. It won't take that much longer. So the net cash flow for this is still the inflow minus the outflow. This is net present value. In fact, we're going to work out the net present value first. So 16,000 in, 2,008, 14,000 out. Now it's actually at 0%, but I can quickly copy those across, and then the net discounted cash flow year 1 is the net cash flow year 1 times the discount rate, which of course is still 14,000 because it's 0%. But as I go along, we can see in year 1, 14,000 at 3% is worth 13,593. 14,000 at 15% is only worth 12,174 in today's money. So I can just finish this off. It'll only take a few seconds with a good technique. That's the formula we need to copy down to there, and that's the one we need down here. Doesn't matter which cash flow, it'll adjust the columns, unless of course I put an absolute reference in which case it wouldn't. This technique wouldn't work. That's not going to work. It's a bit sensitive, this. It used to be worse on older versions. There we are. So we've got our numbers in. That's obviously all at 0% anyway, so everything's at the right number. And I'll just go to quickly fill in the gaps. Open. So in year 5, 18,500 at 15% is only worth 9,198 today, where if the cost of capital was 6%, I'll put the percentages down the bottom, the same amount of money would be worth 13,825 in today's money. So now we just need to calculate the net present value. It is quick formula equals just the sum of them, 14,500, so it's positive as it should be. That actually is the cumulative if we did payback, because it's not discounted effectively. And then we've got our net present values calculated, and actually it's filled in the answer to the argument as well, but I better explain that, how it worked. So the net present value is positive here and negative here. So have a look at the graph. After lots of removing boxes and changing axes and stuff like that, I managed to get a graph that works. So IRR, our net present value would hit 0 somewhere in the middle here. It's about 7.5%. If you don't think your eyes are playing you up, this is actually a slight curve. So what we really should do is look at that and say, we really should have calculated it to be precise on 7% and 8%. But we can use the formula on 6 and 9%. The difference will be about 0.02 or 0.3 because of the curved nature of this line. But obviously Excel is not very good at doing curvy lines anyway, so it's probably worse in reality than it looks like on the graph. So we've done the formula. Okay, so what have I done? Okay, the 6%. So the 6% is because the last known positive value I've got was 6%. The 2534 is the distance from the positive to negative. Now the 4978, I've used the abs function on to get rid of the minus, is 2534 plus the 2444. So I've done 2534 divided by 4978, and then I've times it by 3 because the difference between 6 and 9 is 3. And then when I do the formula in full glory, lots of brackets, an abs formula in as well to turn the minus 2444 into 2444. It works out pretty much what we expected, 7.53. I think if we use 7 and 8% it works out at 7.51. And that's all it is. We're working out the proportion. It's called interpolation, or a mathematician would call it interpolation. So this project earns a discount factor of 7.53%, which can be compared to any other investment or an alternative project which may have a different capital expenditure, a different time span. It still works out and it's still comparable. So level 3, the questions are fairly straightforward. Having actually done the maths, it helps. So if a question told you that 6% was a positive figure of 2534, that's where we've got it from, and 9% gave a net present value of minus 2444, what is the IRR? Well, we've actually worked it out mathematically, but now you know instantly which box to tick. It's definitely not 0%, it's not 6% because that was positive, it wouldn't be 9% because it's negative, and 20% is going to be very negative. It's going to be the 7.5%, and that's the answer to the tick box type questions that used to occur on MMAC, now in maths on the AQ22. So we've looked at all the different methods and even drawn a nice graph.